Hello and welcome to an absolutely new series that I've been asked for time and time again. People ask me how I've been messing around with my game and how I've been making it, developing it, how I taught myself to code, and I figured that if someone had made a clear tutorial. Now there are a lot of tutorials out there, I'll say it, but I feel like I can make it a little bit clearer and a little bit more hands-on on how to do this, because how I taught myself was pretty much looking at other people's code and messing around with it, and I really do support that. If you're ever interested in how a game works, lots of times you can find the source code for that game, go into it. Good example, Minecraft with MCP, where they decompiled the entire game. You can go through and edit stuff and learn how everything changes. But today we're going to be using Unity to make, may not be your first game, but we're just going to say that in the title, how to make your first game, because we're going to go through everything you need to succeed. I just actually stole that from the Unity webpage. Before we start, I have to give a quick shout out to Brian in our soccer game, who got a beautiful flick. He actually leveled number 6. Rest in peace, number 6 on the other team. He just got wrecked. Absolutely. So we're going to have a small moment of silence for number 6. Okay, now that we have had that moment of silence, I think it is time to begin our journey. So I'm both going to be teaching you guys how to program in C# and how to use Unity. And so, how we are going to start is how to install things, because you kind of need them. Unity is free. Just press Get Unity Now on the Unity site. Download now, free version. But wait, don't click on this. This will not give you the best version of Unity. You want to go down here and click Unity Beta Releases. These are the newest releases. There are a few bugs in them, but they have the newest, Actually, this is one version newer than mine, but that's okay. I'll update that later. But this has the newest advancements and features, which is why we're going to be using it. Honestly, there's no point not to use the beta, really, except for the occasional crash, but after you do anything, you should be saving anyways. And the second program we're going to be using after you install this is Microsoft Visual Studio for code editing. Now, you don't need to use Microsoft Visual Studio, but I highly, highly, highly prefer Visual Studio to the default mono develop for a variety of reasons that I'll go over while coding. But so once you have those two, which we'll just close out of, now we can start. We're going to open up Unity for the quote-unquote first time, if you haven't worked out on it before, and we're going to create a new project. You can see all of my projects here. I have quite a few projects. Most of these were small projects that never really got anywhere. Actually, this one worked really nicely. I had my Island Generation one, Blood and Steel. That was supposed to be some sort of game where you're like an armored knight and you fight online. Fusion was supposed to be a scientific app, but a game like with the elements and stuff. Well, let's just, maybe I'll go through all of my great ideas later, all these things that I've been working on. Mostly my two main projects right now are Sandblocks, which is basically a sandbox, but a sandbox where you'll be able to basically create your own stuff and program within the game. Definitely not a rip-off of Roblox at all. And then we have Voxel Space, which is my voxel game in space, if you couldn't tell. So we're just going to click New, and we're going to name this, I'm going to just name it YouTube game. I don't exactly know what we're going to be doing in this game yet. I think we're just going to grow the game from where it starts. We're going to create this project. We're going to see it makes a little folder for it wherever we specify. It's going to build the game for us, and wait for it, and now we have our game. Now, this is not where we want our game to be. Currently, it is just the sky, a play button, which that actually isn't there in the actual game. And we have a light and a camera. Lights, cameras, action. So now if we press this play button, we will just be looking out. It needs to compile very quickly for the first time. And we will just see the sky. So we have a bit to add. So to start off, we are going to do probably the smartest thing yet. And we're going to add a bunch of folders. And we're going to name this resources. You need to spell that one correctly, exactly like that. The resources folder actually is very important. It's a part of Unity, and you don't want to screw that up. Now the next one, I usually make a folder for code, and then I make a folder for art. Some of the art stuff, actually I'm going to put the art folder under resources so that we can load the art if we want after runtime. But now we have pretty much the basic setup for our game, and we're going to make another folder, and we're going to name this one scenes. In Unity, like most other game development studios, you have scenes, which are basically, you could think of like levels in a game. Some games will only ever have one level, really, other than like loading screens, like think Minecraft again. Some will have many. Think, actually, Half-Life 2 hid those loading screens pretty well. So think games like Call of Duty, where you have the lobby, you have the main menu, and then you have like zombies and multiplayer. Those would all be different scenes, and they would all be coded differently. For our purposes, we're just going to start by creating a single scene, and this one is going to be called game scene. So, now that we have this, we're going to open this. It's going to open the default scene, so nothing should actually change. If something does change, well, that's interesting. Okay, I just turned lighting on and off for a second to see if it would affect the skybox. But, so the first thing we're going to do is go game object. Game objects are basically what your game will be made out of. Every object in the game is a game object. Game objects can have special scripts called mono behaviors that are run off of them, and those have a few special properties, which I'll talk about in a second. So we're just going to put this platform down, a plane. If you double click on something in this hierarchy down here, it'll focus in on it. And your layout, I probably should have said this earlier, your layout may not look exactly like this. I think by default the hierarchy is up here in one of these tabs. So I apologize if I've completely confused you. This is the layout I usually use because I usually don't have much stuff in the hierarchy. So we have a platform, and now we can basically say that our game is officially a platformer. Yeah, bad joke. Okay. You don't. It's okay. I know it's a bad joke. Now we are going to add the first actual object, other than the floor, which is going to be, let's make it a capsule. In this capsule, if we move it up a little bit, we have up here, we have the move tools, rotate tools, top left, resize tool, and this is for UI. I wouldn't really worry about this, but it's just a fancier resize tool when you're using UI. But we're going to keep that capsule pretty much the same, and this is going to be our player. So we're going to click on it. Up here on our inspector, we're going to name it, if I can spell, I really can't spell. We're going to name it player. It'll be named player down here. We'll save very quickly by doing Control S or just doing File, Save Scenes, and now we have the player. Sad thing is, the player actually won't do anything yet. So we have to do two things. First off, we have to put the camera into the player, which pretty easy. See the hierarchy? Just grab the camera, put it into the player, and now on the position we're just going to set these all to 0, which will put it perfectly in the center of this capsule. And because we want it to be somewhat where the head would be, we're going to move it up a little bit. There we go. Now we are technically the player in the capsule, but we still can't move the player or anything. So we're going to start with the first script, which, what would this first script be? To move or to turn around and look around? Actually, we'll just do it all. We'll call this player controller. So you just right click, create, script. I put this into the code folder. Maybe you even want to make a folder within the code folder called player and put all the code for the player in there. And now we're going to go into here, and here's player controller. We're going to open this. If you didn't install Visual Studio or didn't set it up, there's a great tutorial on the Unity site on how to link up Visual Studio with Unity. You will have Mono develop. Mono develop doesn't suck, but it's going to look a little bit different and be a little bit more frustrating. So I definitely suggest you get Visual Studio. It's absolutely free. It has a dark theme which looks amazing, and it's basically got everything plus more than Mono develop. So first thing you'll notice is it comes with this. These are our two default methods. Start will run when the game starts, and update will run every time your screen refreshes, which in a normal game will be around 60 times per second. If you're playing on a console, no hate guys, it's just a fact. Most games are locked down to 30 FPS on a console, and if you have a screen like mine, we can go up to about 144 updates a second. If you want something to be stable and not change depending on how fast your screen is refreshing, there is a fixed update, which you can define how fast it runs, but we aren't going to be using that yet. There's no need. Usually you'll just be doing things every frame, and you may worry about that causing lag. Yes, you shouldn't be doing heavy calculations in the update. You really shouldn't. That's one way to kill your game really fast. So I won't get into too much of what this is or this yet. Well, this just kind of says this is a class, which is basically just saying this is a piece of code or a script. It's called player controller, and it's a mono behavior, which means that we can put it onto game objects. So we're going to start with start. Actually, no, we aren't. We're going to go up here, add a few spaces, and we're going to write public game object camera. Actually, nope, we're going to write public camera, and we're going to make this one lowercase. Cases do matter. You don't want to mess that up. Is this going to get mad at me? Dang it. Okay, and we'll name this player camera. Haha. There we go. It's not complaining now. We'll make public. Actually, we can pretty much get off on just that for now. And what we're going to do is start. You know what we will do? Public game object. One of the nice things about Visual Studio is as you type things in, you can press enter and it'll do it automatically for you. Public game object player, and that will just refer to the object that is holding this script. And what we'll do is we'll say player within start. So right when this starts, we're going to say player equals this. So this script dot game object. So that'll just get, and you don't have to write this dot. But I prefer it because it's a bit simpler. You can see what's going on. So the player is being set to the game object connected to the script. Boom. And now when that runs, this variable here is going to be set as the game object. And then we're going to say, this is the first time we're going to be using a Unity method or calling a Unity method. We're going to say player camera equals this dot get component in children, which basically means when you put the main camera under player, that camera is now a child of the player because it's under it, and the player is the parent of the camera. So we're going to get the component in the child, which is the camera, and in these I don't want to mess this up. Arrow things, that's the technical term. We're going to put camera. Bam. So we're going to get the component camera in one of the children of this game object. And now we're just going to do this because these two parentheses here mean that we're calling a method. We're just going to put semicolon after it. Every line should end with a semicolon. That basically says this is done, go on to the next command. If you forget it, it will throw a ton of errors, or just one, and it'll probably tell you what the problem is. We'll get more into debugging once I actually make a mistake, which is bound to happen soon. I'm not perfect, and I'm only going off of like a half-done script here, so we're going to make a few mistakes, but I'm planning that because if you don't make any mistakes, then I can't teach you guys how to look for the problem. And debugging is the longest and most challenging part of programming. So, yeah. So, now we know who the player is, we know what the object is, and we know what the player camera is. So I think what we're going to do is we're going to start with making the player move. So we're going to say if parentheses, oh, and we're not going to put brackets in it, and then we're going to put brackets after in, and this is basically saying if this, then it'll run whatever within these brackets. So we're going to say if input dot get key, and then key code dot w. So this is saying if the key W is gotten or pressed, then it'll do whatever here. Get key down would return only the frame that it went down, and get key up would only give the second it went up. Well, the frame it went up. Get key will continue returning true as long as you're holding it down. And now we'll do player dot transform. The transform is the it's slightly hard to explain. A transform basically stores the position and rotation of something. So if you want to change the position of something, you'd use transform. But I just decided we're not going to use that. We're going to make this game true to physics. So we're going to move this over, click on our capsule here, add component, and now we're going to search rigid body. Rigid bodies basically are the basis of physics. Things that have a rigid body have a mass, they have drag, which we're going to set the drag to 0.1, which means that we'll slow down from drag. And they also have friction, they will bounce off of objects, but you need a rigid body for this to work. And now what we're going to do is we're going to go back to our code and we're going to make a reference to the rigid body. So public rigid body RB, and then in the start function RB equals player dot get component rigid body. Bam! Look at that. Now we are setting the player, the player's camera, and the player's rigid body. And now since we know what RB is, we can call RB dot add force, and now we have to add the force, and we're going to add another public variable here. I'm going to call it speed. Public, do I want this? I'll make it a float. Speed, or I'll even make it walk speed. And I'll make another one called run speed. So we'll add a force, and we're going to go transform, which is basically holds the position and stuff, dot forward. So this is saying we're going to add a force to push it forwards, and we're going to do times walk speed. Now, what we can actually do is copy this, paste this here, and we can actually, how many times are we going to paste this? We're going to paste this, oh, I just did Control C instead of Control V. We're going to paste this 2, 3, 4 times. So this one's going to be W, S, A, D. And then we're going to have S be transformed backwards. Oh, actually, they don't do that because you can just do negative transform dot forward, which is the opposite of forward, which would be backwards. And I think they have for A, which is on the left, we can go, I think they only have right, so we'll do negative transform dot right to go left, and then D would be to the right now, so now we just write right. And that's WSAD. We can go in all the directions, and now this right here, we're going to now on an American keyboard next to the bracket keys, or the other bracket keys, you're going to have this key above the enter key that has the backslash and 2 dots on top of each other. Click those 2 dots on top of each other twice, and it'll give you these bars. Now, after these bars basically say OR. That's not what we wanted. I just had a brain fart. That's good to know, because that can make it so that if this or this, instead of just writing the if statement twice, but what we're going to write is and. So, if we get the key W and we get the key code dot left shift, we're going to add forward times run speed. So now we will go, if we get W in shift, it will run. This is pretty advanced stuff. No, not really. It's going to get much more advanced than this. So if you understand for the most part what this means, then that's good. We're basically just calling functions, which functions are basically just this right here. Update is a function. A function just contains code to run, and when you call it, it runs the code. And we pass the variables to it on which key we want to be pressed, or yeah. If we get the key W, we add a force to move it forward. If we get S, we go left. If we get A, we go right. If we get D, oh no. If we get A, we go left. If we get D, we go right. If we get W and shift, we run. So now if we save this, move it over again, and we're going to quickly grab the player and drag player controller onto it. We're going to set the walk speed to 2 and the run speed to 4. And now when we press play, we're going to see right here, these all set themselves. It found the camera, it found the player, and it found the rigid body. Now if we click on the game view, you know, I really should have thought of that. Oh, jeez. Yeah, I'm smart. Yes, we pushed it backwards and it just fell over because, yeah, that's how real physics work. If you were a capsule, you would fall over. So, I can't believe I just made that mistake. But we're going to right click on the capsule collider. We're going to remove it. We're going to add a new component. And we're going to search box collider. Now we're going to fix this with a bit of code later, but this episode's ending soonish, so I'm just going to give it the fast solution, which is make a collider where it won't fall over. You may see that it's a capsule, but the collider is actually what makes it detect that it's touching something. So having a cube around it, this is where you get horrible hitboxes in video games from, because if my mouse was the gun, if I shot here, it would detect it as hitting the player because of this green line here. It's saying, well, it's inside of the box, and the box is all it sees. There are mesh colliders too that perfectly align to the mesh, but we're not going to bother with that because it will just fall over again. Now we're going to press play, and bam, we are going to fall. Oh, geez. When we add that force, we are actually just throwing the force onto the side of it, which normally, if we were on wheels, that would be fine, but we are not on wheels, so I'm going to rethink. This is going to become a very interesting game following physics like this. Okay. But do I want to do the boring solution? I did the force thing because that's what I did in voxel space, but voxel space is in space, so I completely disregarded that there was any friction. I was thinking about space. Could we make a space game? Yes, actually we could. We could make a very simple space game, and hey, that's not actually a horrible idea. Actually, I'm cool with that. Let's make this a space game. Heck, we won't make it a full voxel game because that takes way too much time and effort, but we'll make this a space game because we needed a theme and I slightly screwed up by assuming it was going to be a space game. So, it's going to be a space game, guys. So now we're going to get our capsule. We're going to press Edit, Project Settings, Physics. And right here, this y negative 9.81, we're going to set that to 0. There is now no gravity in the game. We're going to go into our code, grab our player controller, pull it over, and we're just going to add 2 more lines, which are going to be, oh shoot, oh well, if input dot get key code dot space, it's going to make it go up, and if input dot get key code dot left control, it will go negative up. I probably shouldn't have called it walk speed. We can change that later. I guess walk speed works. It's not exactly walking, but it's the best word we can get for the occasion. Now, if we press the buttons, we will notice we are floating away, because even though I added a small amount of drag to the rigid body, it's still adding a lot of force. So we can actually zoom around. We can't turn our character. We have not coded that yet, but we can fly around and we can tell that we are actually moving. This script is working perfectly fine other than the fact that we can't turn, but that will be next episode. Oh no, we've fallen. We're rolling. No. Oh, we're out of control now. This is not good. Wow. Houston, we've got a problem. So thank you guys for watching. If you enjoyed this and want to learn more on how to do this stuff, I will continue making this space game, and maybe at the end we will throw it on an app store or something. I don't know. If you guys really need source code or it was too confusing and you have questions, just say it in the comments. I will post the code all online if you guys need it, but it's a slight amount of work, so I'll do it on a if I need to basis. So thank you all for watching. Leave a like and subscribe if you want more, and I'll see you all next time. Oh, oops, I actually have to hit the stop recording button.